So yes, we have seen an experiment performed by Faraday. Okay, we have seen the observations, and what was the conclusion? That whenever there is change in the magnetic flux, when we move the magnet either towards or away, what happens is the coil, okay, there is a coil and the magnetic flux linked with the coil changes, and due to that there is EMF induced. Okay, I studied about EMF in current electricity. Voltage is produced due to which there is current flow. And when there is no change, means we don't move anything, either the coil, relative motion has to be there. Coil is stationary, magnet is stationary. That time there is no change in the flux, and that time that's when no EMF is induced. So whenever there is change, very important thing, whenever there is change, this whole chapter is based on this. So to understand this clearly. Whenever there is change in the magnetic flux into a coil, there is EMF induced in the coil. That's the first thing. Now, on which factor the magnitude, how to find that how much EMF is induced? The magnitude of induced EMF is directly proportional to rate of change of magnetic flux. How fast we move. That's a factor which will decide the magnitude. So, the magnitude of induced EMF is directly proportional to rate of change. First, you have to find how much change is there, divide by the time, rate of change of magnetic flux linked with the coil. That is d phi by dt. Okay, or you can even write, either you can take the derivative if expression is given, or if you know change in EMF phi 2 minus phi 1 upon t. This way also any formula you can use. Now I'll tell you, so E is EMF, induced EMF, which is given as minus d phi by dt, that is rate of change of magnetic flux. Or minus. Now why this minus sign is there? Because the direction of induced EMF is such that it opposes the cause. That we will see in the Lenz's law again.